This section is going to be really short because all I'm going to do is introduce the concepts behind options valuation. And then I'm going to have you guys use some online calculators to practice with it. There really isn't any math that you will be doing in this section. You will learn about how to do the actual valuation process in 495. So in general, options have two values. The intrinsic value is what you've talked about so far. So you know that a call is in the money, at the money, or out of the money, right? And if it's in the money and you can make a profit, so this is a long call, let's say the stock price is above the strike price, then the intrinsic value is the difference between the stock price, the strike price, and any premium that you paid, because that would be the amount of money that you actually make. And vice versa for a put, so on and so forth. But there's also a time value associated with options. So that's the idea that even if it's not in the money now, it still could move into the money at some point in the future. So the time value is an additional factor that we need to consider. And the way we do that is through present value calculations. So for a call option, the lower bound of the call option value, the upper bound of the call option value is the current stock price. The lower bound is the present value of the strike price plus any present value of dividends that you might receive. So what happens is the value of the call approaches the present value of the strike price plus the present value of the dividend over time. Now that happens through a mathematical process, and I'll show you a little bit of that in a bit. So when we price options, both using the binomial options pricing model and the Black-Scholes options pricing model, we do so assuming they are European options. Now recall, a European option can only be exercised at the maturity date. So if you have an in-the-money call, do you exercise or do you wait? Well, if it's a European option, there's nothing if it's in the money and it's not the exercise date, then you can't exercise early, so you don't exercise early. But if it's an American option, you could exercise early. But what we end up discovering is that there's no point in exercising early as long as there are no dividends that will be received until after the option expires. The call gains value as the stock price rises because the price will rise indefinitely. The call is said to be worth, quote unquote, more dead than alive. In other words, you would not rationally exercise a long call early, even if it's an American call option and you could. It's different though for put options. American put options are actually worth more than European put options, all else equal, because the possibility of early exercise is not equal to zero because the value of the stock cannot fall below zero. So when it's an American put option, note that approach is, this is a little less steep. We're not just concerned with the present value of X, the strike price. We're concerned with we look at the actual value of the strike price. So that's why American put options are worth a little bit more. Now, here's an example of a binomial options pricing. A stock is currently trading for $100. So the current stock price is $100. You believe the price next year could go either up to 120 or down to 90. So its up movement would be 1.2 and its down movement would be 0.9. With binomial options pricing, it's called binomial because you're looking at two possible movements, either up or down. And those degree of up or down movements are a function of the volatility or the variance or standard deviation of the stock's historical prices. So if this option has a strike price of 110, then the call options value would be what? Well, if the stock price goes up to 120, you have the right to buy at 110. The call options value would be 10 in year one. In the up position, it would be 0 in the down position, because why would I buy at 110 and turn around and sell at 90? that would give me a negative return. I don't want to do that. So you just leave the intrinsic value as 0. And you can continue this process on and on and on through a binomial options tree. And then what you do is figure out, move successfully, back through this tree and figure out the value at each stage, and then use that to find the value of the option at time 0. Now, you could do this a gazillion times, and by increasing the number of sub-periods, it allows for greater refinement. As the sub-periods increase, the probability distribution approaches a bell-shaped curve. So here you can see the values of U and D are derived from the standard deviation. So U is, and now we're going to move into continuous time here. U is equal to the, this is e to the x in your calculator, right? Standard deviation times the square root of the change in time, and the down movement is the negative of that. So as we increase the number of time periods that we examine, so panel A shows you 3 time periods, panel B shows you 6, panel C shows you 20, notice that it's starting to approach a standard normal curve, which means that we can take advantage of our knowledge of the normal distribution. And this is what allows us to come up with Black-Scholes options pricing valuation. The way it works, we're going to use X as the exercise price. E is that e to the x that you have in your calculator. And here I gave you the value of E as 2.72 roughly, right? And then what else goes into that? The risk-free rate annualized on a continuous basis. T, the time to maturity. You need a natural log function, the standard deviation of the stock. So the value of a call option can be found using this formula. Where S sub 0 is the current stock price. And you will examine some Excel calculations that apply this methodology.